Equation y equals x squared. I don't know, look at that square root. So the first thing I'll do is rewrite the question, making it a little bit more friendly, I think. So friendly to differentiation, of course. So y equals x squared minus 2x minus 24x to the half. Right. So let's go ahead and do part 1, differentiate at once. So you can see that dy dx is equal to 2x minus 2 minus 12x to the minus a half. And furthermore, if we go ahead and do the second differential like they want to, let's do so d2y dx squared, make sure we get that way around, please, is equal to 2, and then minus 12 times by minus a half, obviously plus 6x to the minus 3 over 2. Okay, so that's going to get us our first 3 marks. Verify, it says in part B that C has a stationary point. In other words, it's got a flat bit when x equals 4. So if a curve has a flat bit, either it's a maximum or a minimum, of course, the gradient is going to be 0. In other words, the dy dx is going to equal 0. So let's stick x equals 4 into the gradient function and just check that it does, the gradient is indeed 0. So here we go. I'm evaluating dy dx when x equals 4. So here we go. 2, insert the 4, minus 2, minus 12, insert the 4, minus a half, and clearly 2 4s are 8, minus 2, and the square root of 4 is 2, but it's the reciprocal of 2, which is a half, and a half of 12 is 6, isn't it? And you can see therefore that 8 take away 2 is 6, and 6 take away 6 is 0, so we can conclude that there is a stationary point. Okay. Right, the last part, we're going to need a little bit of space, so I'm going to delete some of this stuff, but it wants us to determine the nature of the stationary point. In other words, it wants to know, have we found a maximum, concave, or have we found a minimum, convex? And we can know the difference when we evaluate x equals 4 in the second differential. If we should get a negative value, then we know that we have a maximum, and if we get a positive value, then we know that we have a minimum. And if we get a 0, it might be that we have a point of inflection, and we can check for that as well. But let's just see what happens when we evaluate the second differential for x equals 4. So if you don't mind, I'm just going to make a little bit of space for myself. Okay, there we go. And here we go. So I'm evaluating the second derivative at x equals 4. 2 plus 6, 4 to the minus 3 over 2. Well, the square root of 4 is 2, and 2 cubed is 8. And this is a reciprocal of 8, so it's an eighth, which looks to me like 2 and 6/8, or 3/4, or 2.75 if you prefer. In any case, it looks very, very positive to me, in which case I'm going to say that at x equals 4, okay, we have a, well, it's positive, so we have a minimum, local minimum. Okay, I hope that's helped.